So once again, try problems 4 and 6 in both sections, so 4 problems in total, all the way through by yourself. If you haven't done this, pause the video, try it out, but I'm just going to do problems, both the problem number 4s in both sections. I'm not going to touch problem number 6 in either section. That's, if you really want me to, feel free to message me. Let me know if you want me to go through it. But otherwise, I'm just going to go through problem number 4 in both sections, and we'll just take it from there. Okay, so number 4. If there's a force of 120 newtons exerted on a 40 kilogram crate, causing it to move at a constant velocity, what is the value of the coefficient of friction? What is the force of friction? So it's asking for 2 different things over here. And once again, all that's really saying is that we're exerting a force on a 40 kilogram crate, moving it at a constant velocity. Okay, so let's just draw our free body diagram. You should definitely know this by now. And we're exerting a force. I'm just going to say that it's a pushing force to the right, and this is going to be my applied force. And I'll have a frictional force. What kind of friction is it going to be? Well, we know it's moving at a constant velocity, so therefore it's going to be the kinetic friction. All right, and so this is my free body diagram over here. What is the given information? So I have a force of 120 newtons is exerted, so I know that's my applied force. Okay, 40 kilogram crate. Moving at constant velocity. So if it's moving at constant velocity, then what does that tell us about our acceleration? Okay, what is the value of the coefficient of friction? And what is the frictional force? Okay, so we have our problem set up right now. Now, the next thing I want to do is let's find out what our weight is. So the Fg okay, so I have 392 newtons right there. I'm just going to say that my upwards force is going to be positive, and being that this object is going to the right, it's also positive. Okay. Alright, so all the forces going upwards, minus all the forces going downwards. This is going to be equal to 0. And all the forces going to the right, minus all the forces going to the left. And this is also equal to 0, considering the idea that we are moving at a constant velocity. Okay, and we know that we're going to be looking for our kinetic friction and our mu k. So we have our kinetic friction in this equation over here, so let's work with that. And we have our applied force, which is 120 newtons. Okay, and we have our 120 newtons right there. Perfect, okay. And we also want to find out what our mu k is equal to. And we know that our kinetic friction is equal to mu k times our Fn. Okay, well, we have the value of the kinetic friction, which is 120, is equal to mu k times our Fn. We don't have Fn over here, but we do have it over here, our normal force. So let's solve that out. And our substitution of 392 for our force due to gravity. And all we have to do is a simple division over here. Divide 392 on both sides of the equation, and we will get our answer of 0.31 as our mu k. And there you go. That's the first problem.